so we have covered the quiz for chapter 2, right? The end of chapter 2, and currently we are learning chapter 3. Hopefully we can finish chapter 3 today. And also welcome for, surprisingly, there are newcomers. So we'll have to discuss something at the end. Now, just to refresh, we have covered how to deal with vector in chapter 2. We have covered how to deal with equilibrium of particles in chapter 3. In 2D and also in 3D, right? We have covered one example, I think, in 3D. So this is straight away a continuation where we left off. The second example. Now, unfortunately, this thing is stuck. So hopefully you can still see. I think it's more challenging from the back. But if you have, because on Atalim the slide is there, so if you cannot see, hopefully you can see from your phone the slide from Atalim. Right? Now, so in this question we have. So if you still remember the previous question, the difference here is that the previous question is already given in free body diagram, right? Where your particle and forces here, we have like the cables or the cords is shown here, and you have to actually draw the free body diagram. Right, so the question here is that we have the 600 Newton load supported by 3 cords or 3 cables with the geometry shown. And we need to find the tension in each of the cords, AB, AC, and AD. Right. So if you can see, there's like a ring here, falls downward, and then you have the 3 cords. Right. So the first thing is to draw the free body diagram. So if we consider this as the axis, okay, and this is the particle A. Right? So basically we have the 600 Newton going down, straight down 600 Newton, and then we have, so to replace the chord from A to B, we draw the force, and that chord is on the XY plane, right? So it's something like this, and it's there with the angle of 30 degrees. So we can label it, for example, F, A, B. And then point C to point C, so the course is straight away on the x-axis. So this is the x-axis, y-axis, and z-axis. So that this one is straight away going to the back here. Let's say FAC. And the other one is somewhere here, was there, FET, with the value given 1 meter, 2 meter, and 2 meter. Okay, so that is basically that is the free body diagram. So any question with regard to how to establish this free body diagram? From this one, it should be straightforward. Yeah. So again, in the exam, free body diagram is one of the things that we heavily assess. So make sure you draw properly and do not miss any information, right? And also differentiate what need to be differentiated. For example, between axis and forces. Should be quite clear which is which. Now, what is the question again? So we want to find what is this unknown. 1, 2, 3. How do we do that? What's the concept that we apply here? So this is equilibrium problem. So basically, summation of all forces should be equal to 0, right? Or in scalar form, summation of fx equal to 0, summation of fy equal to 0. Summation of fz equal to 0. Right. So as long as we can get all the x, y, z component of all the known and unknown, then we can actually calculate using these three equations to solve for the three unknown. Right? So first, let's express each of the force in Cartesian vector form. Okay. If you call this one, this is straightforward. Right? So if you say F600, just name it that. So it's basically 0R plus 0G minus 600 K Newton, right? What about FAB? What is the X component? What is it?
FAB sine 30.
So FAB sine 30. Alright, everyone get the same?
Yes.
Do you know how to get this?
Yes.
So that X component there, right? And then what about Y component? The Z component? 0 K. Right. So this is basically using what we have learned in chapter 2, I believe, right? So what about FAC? What's the X component? Negative? Negative what? Negative FAC. Alright. Y component? 0. Z component? 0. Okay. What about FAD? How do you get this in vector form? What method do you use? Of course, there are several ways to do it, but which one do you think is? You use the coordinate and position vector, is it?
Yes.
So if you calculate this RAD, the vector what will be? What will be the X component? 1I negative 2J plus 2K. Do you know how to get that?
Yes.
Using basically the information here, right? This is positive, this is negative, this is positive. So RAD will be square root of everything here, right? Square root of that. Huh? Get 3, right? 2, 4, 8, 9, 9, square root of 9. So UAD will be, let's say we divide, so 1 over 3I minus 2 over 3J plus 2 over 3K. So for the FAD, you just multiply this with the magnitude, which is unknown here, right? So what do you get here? 1 over 3 FAD I minus 2 over 3 FAD J plus 2 over 3 FAD K. Alright, so we have expressed all the four forces in Cartesian vector form. What to do next? So we apply this equation of equilibrium, right? What do we do is that we add all of this. Basically what we do here is summation of fx equal to 0, right? And if you add all of this, you have summation of fy equal to 0. If you add all of this, you get summation of fz equal to 0. Right? How many unknown do you have in this equation? 1, 2, 3, right? This equation? 1, 2. This equation? Only one unknown, right? So it should be obvious where you should start, right?
Yes.
So if you start here, then you do summation of fz equal to 0, and then you have minus 600 plus 2 of plus 2 over 3 FAD to 0. So FAD you can straight away solve, right? And then with FAD is solved, then meaning this one is solved, you can go here, right? So if you go to this summation of f equal to 0, what you get is f a b cos t minus 2/3 900 equal to 0. So f a b you can calculate, right? So meaning after that you have already f a b, so you can calculate for summation of f c, right? You have to calculate for f a c. So f a c can also be solved there. So the calculation is just mathematically solve this equation. Of course, in this problem, it's very straightforward and very short because you have a lot of 0 here, 0, 0, 0, 0, 0, right? Because it's in the specific axis like that. Like if everything is like this, then you'll have something like which one? This FAG, yeah. You have unknown everywhere, right? So you will not have 0 like that. Right. So again, I think I have repeated this so many times. The examples that I have put into the slides are normally the easiest type of question that you can get in the book, and normally in the exam you never see question as easy as this. So make sure you try also some of the other problem in the book. This one is just to show the steps, right? And because the rest is just mathematics. How to get this part is, this is still not really static, it's just beginning of, because in the later chapter we will apply a lot of this for a longer calculation, right? Any question? Is it clear what to do from the free body diagram? You know you have to apply equation of equilibrium. You know how to establish each Cartesian vector form or XYZ component, and then you know how to apply and solve, right? So hopefully no problem there. So if you have solved, and it should be giving this kind of answer, right? So it doesn't actually involve simultaneous equation because you just solve one by one, right? Since it's positive, it's assumed. It is as assumed. Now, in this case, it should be positive, right? Can it be negative? If you get any negative answer, what should you know about this? Something is wrong, right? Because we are dealing with cord or cable that cannot be in compression. So we have discussed that one. You should if you suddenly get any negative answer, you should know you have made a mistake. Any question? Anything not clear about how to solve? Straightforward, right? We are still chapter 3, so everything should be still straightforward. Concept quiz. In 3D, when you know the direction of a force but not its magnitude, how many unknown corresponding to the force remain? So how many unknown? If you know the direction but you do not know the magnitude. 3. What is the 3? What are the 3? Apa yang IG ni? Meaning the unknown is IGT. Can you imagine a force that you actually know where the direction, meaning the direction is known. You don't know the magnitude. So how many unknown do you have? 1. Apa yang 1 tu? So okay, in this case, right? For example, this one, this is an example, right? You do not know the magnitude, but you know the direction already, right? This describes the direction, exactly in that direction, right? How many unknown do you have? You have 1, right? This is the same unknown, of course. Now, if you have a force like this, right? P, for example, right? And you do not know the direction, you do not know the magnitude. How will you write the vector? Pxi plus Pzk, right? How many unknown? 4 lah. 1, 2, 3, right? Yang ni jangan masuk ni. Right? So for that force you have 3 unknown, right? So that's the difference. If you actually know the direction, then it becomes 1 because everything is still expressed in one unknown only, right? So that's just to see if you catch that concept. Anyway, most probably this kind of question, because this kind of question is just to see whether you get the concept, right? And most probably it is not in the exam. Right? Most probably too, meaning there's some still small probability. If you have seen the previous exam papers, you will see that most of the questions are calculation based, but there will be 10% marks for question like this, where you see concept question where after your calculation and then there's some question like what if blah blah blah. So you have to answer in sentence, right? So that is based on if you understand the concept or not. Anyway, so it's just some say it's just 10%. But 10% is like it changed your grade already, right? So anyway, if a particle has 3D forces acting on it and in static equilibrium, the component of the resultant force will be which one? Ni kau tak dapat jawab ni memang kena drop. This should be very straightforward, right? The resultant should be equal to 0, right? If it's equilibrium, the resultant has to be 0. Alright, so let's take a look at this example, which is a bit different in terms of the original picture, right? So we have 17500, 17,500 Newton motor and plate. So basically the weight of this motor and the plate together is 17500 Newton. And this is in equilibrium. And the whole thing is supported by 3 cables. So I have this one cable, and one cable. So we need to find the magnitude of the tension in each of the cable. So what is the tension here, here, and here, right? What should we do? What do you need to do if you have this question? What's the first step? Okay. So what will be the body of the diagram? Alright. So this is where obviously in this chapter we are dealing with free body diagram of particle, right? So it's quite we consider point A. But later we will learn also how to draw a free body diagram of object like this. Right? So it's important to know, okay, this kind of question, what free body diagram you need to draw, because it will be different. Right? In this case, we just focus on point A. So at point A, so this is the particle that we are considering as the body. So of course we have 175 Newton there, and then we have another 3 forces from the 3 cables there, right? So one, another one, roughly like that, right? And then this is actually going to a certain point on the plate there, right? Now, in terms of concept of free body diagram, if the body is particle A, the cable and the plate and the motor should not actually be in the free body diagram, right? We have discussed that because that is external thing. But what we are concerned about is this dotted line is not part of the structure, just to show the direction, because we need the coordinate to calculate for the vector, right? Right. So we can label this. Let's say this is FAB. BC, AD, right? Where this is BCD for reference point. Now there's a difference if you draw something like this, huh? But I'm not sure whether we should be strict on that or not. But in terms of the meaning, because I always stress on it should mean the correct thing. But anyway. So what information? Okay, if you have structure like this is sufficient in terms of the information needed, right? It is quite different from the previous one, where from the point you actually have a specific angle, so you have to draw the angle. But here it's just point and point, so as long as the 2 point is, you have the information of the coordinate, that's all fine. Meaning, what is the angle here is not even given, right? Right, so what do we need to do? So this is the flip diagram. So what is the coordinate? So coordinate of point is 0, 0, 3. What does point B? X is 0.9, is it? Negative 0.9. So make sure you do not make a mistake between X and Y. Make sure you take note of the negative. What about point C? Coordinate of point C? 0 point? 1.2 minus D. Okay, we'll write that first, then. Y coordinate? 0.9? 0, right? But what is D in this question? D is given, right? So it becomes 0, 0.90, right? Faham tak? 2.4 dari 2.4. 2.4 dah keluar dari depan. Okay, every semester I should change the example because every semester mesti ada perbalahan ulama. Okay, just imagine if you have, for example, something like this, 1.2 meter, and then for example you have D, and you have X, right?
Yes.
X equal to what? If this is the relationship, 1.2 is obvious, right?
Yes.
And the question can give something like this: what if D equal to 0, D equal to 0.6, D equal to 1.2, for example, right? Obviously X will become something else, right? Even though the drawing is still like that. You kata, kenapa? Why is this like this? Dia tak bergerak. No, because it's not possible. We don't have the interactive screen in front of us, right? So we have a general question where it's not like when you click here, then D moves. But you should understand the meaning, right? When D is 0, actually is here, right? D is 1.6 is here, D is 1.2 is there. That's the meaning of it. Meaning D, you cannot say this is not accurate, sir. I made sure no, this is not meant to be architectural drawing. This is like otherwise you can criticize the thing. I calculate this. If this is 0.9, this is more than 1.2. The ratio, then everything you understand. You cannot deal with that. Like that. But anyway, for those who cannot accept this reality, we just say C is here. Senang. Abang nampak kan? Abaikanlah dulu. Tak panjang cerita tak habis. Okay, so if it's 0, 0.9. Faham ke? For example, if a question gives something like this, right? If this is not given, and there's some other format of calculation and you have to calculate D, it doesn't mean you actually measure from the drawing, right? You have to do some calculation based on something, right? So you have to understand how we draw a question in the drawing and what it means in that sense. But anyway, so we'll avoid question like this in the final. What about point B? What's the X coordinate point B? Negative 1.2, 0.6. Why is? 0.3, is it? How do you get 0.3? Alright. So this is another thing where most people get a mistake because the value given is 0.6, right? While the coordinate should be this one, right? How to get this? 0.3? If this minus this one, right? You don't go measure this one with your ruler, right? So the same concept here actually, if you understand, right? You actually just minus whatever given there. Alright, so we have the coordinate. So what we do next? Draw. With the coordinate, you can actually measure the position vector and then do actually this in vector form. So basically, we'll calculate separately. So for FEB, so REB will be this minus that one, right? So 1.2i minus 0.9j minus 3k, and the magnitude would be square root of everything there, right? And I'm not sure whether the value will be many decimal point or not. But you can calculate that one. So UAB is simply this divided by this one. So 1.2 over whatever square root there I minus 0.9 over whatever square root with j minus 3 over square root of k, right? And then FAB is simply just magnitude FAB unknown multiplied by all of this. So basically 1.2 FAB over square root of something I minus 0.9 square root of something FABJ minus 3 over whatever square root FABK, right? Oh. Now, depending on what is the value here, because if the value become a round number, then that's quite straightforward. But if it has some decimal point, I'm not sure. Does it have a lot of decimal point? Yeah. So as we have covered in chapter, is it chapter 1 or 2? For decimal point. If you put this in a decimal point, make sure you have enough decimal point to minimize the error, right? Because when you divide, etc., the error can multiply. I personally have a habit of conserving it in this way until the end, then when you calculate later on, you calculate so that the error will be 0 up to this point, because we haven't rounded anything yet in this case, right? So that's just a suggestion, and it doesn't, meaning it's not that messy with many decimal points there, right? Now that's for FAB. Then you have to repeat for FEC. So basically you have REC equal to, what is this? This minus that one, so 0.9j minus 3k, right? And REC, so the square root, so UEC, so 0i plus 0.9 over the square root j minus 3 over square root 3. Of course, this one will be different than this one, right? And then FEC, you know what to do, right? Similarly, you do for FED, so RED is minus 1.2i plus 0.3j minus 3k. You know what that means, right? So as you can see, question like this can involve some amount of repetition in terms of the method. So it's not difficult as long as you know what to do. You just repeat the same thing for different values, different forces, right? But that's how it becomes long, right? Because there are a lot of, for each force you have a certain set of calculation before you can establish what is the vector x, y, z, x, y, z, x, y, z component there, right? Of course, for this one, you can express also let's say 1 second. So what to name it? Okay, this is 0i plus 0j plus 17500 Newton, right? Now, I do advise that you also, even though this is quite straightforward and obvious, I do advise that you stay consistent in what you do in the treatment for everything, so that you will not miss anything in the end. I'm not sure if you understand. Because if you express this in vector, this one you do not express because of course you know. But sometimes we tend to mistake or forget about something when it is not expressed exactly the same, right? When you can stick with correlate. So that's just advice for the exam. So it's easier to follow. And then what to do next? After we have get all the calculation as well. Basically, we have the summation of forces equal to 0 or summation of fx equal to 0, summation of fy equal to 0, summation of fz equal to 0. Of course, in this case, you can see how many unknown do we have. Not many unknown. Meaning for each of these, there's not many 0, right? Except for only one. Other than that, you have all unknowns there. So for this question, you actually have to know how to solve using simultaneous equation, right? Unlike before where you have actually one equation where only one unknown. In this case, fx you have unknown, this is 0, this is also unknown. Fy you have unknown, unknown, and unknown, right? Fz unknown, unknown, unknown also. So if you express that, as we can see in the slide, you'll have something like that, right? When you express fx, fy, fz equal to 0, 2 unknown, 3 unknown, 3 unknown here. So you can solve by simultaneous equation to get the value there. Right? Any question? So the rest is mathematical question. Any question on how to go from the question to the free body diagram, to identify the coordinate, to know that you should solve using equation of equilibrium to express every force in terms of Cartesian vector form or x, y, z component, and then solving mathematically. Right? Any question? Is it clear? Okay, so again, again in the exam you cannot write like this. Just solving interesting and then suddenly the answer come out because it's not you cannot, but it's just you will not get any mark because the mark is given at the steps and then until the final answer, right? So that portion you have actually to show the calculation. But the advantage is you can actually verify your answer with your calculator, right? You cannot jump, but when you calculate, you can verify. If you make mistake, then you should know straight away from your calculator. So that's your advantage, which my generation do not have. Now, just a reminder, we have stressed this one when we cover vector, right? When you write like this, okay, just a question. If I write something like this, in the exam, what will I get? I will get something like this, right? Why? What's the difference this and that? This is scalar, that's vector, right? Scalar, this will have a value, will never be 0, right? It will have value, will be something, right? It will only true when it is in vector form, right? So again, make sure you can, because in the slide or in the solution, maybe it's bold and italic. So you might not notice that it should be written this way, right? So make sure you understand that also. Attention quiz. Alright, 4 forces acted at point A, and point A is in equilibrium. So imagine there's point A there. So we have 4 forces, the 3 in blue and 1 in red. So 4 forces act on point A, and point A is in equilibrium. So select the correct force for vector P. Which one is it? The red one. A, B, C or D? Okay, so if you are to write the vector P, how will you write it? What is the x component? 20i. Y component? Negative. Positive. Sampai je kan? Okay, betul lah. Ada? Ada dua depan. Ada negatif, ada positif. This one everyone agree. But this one some says positive, some says negative, is it? Okay, anyone say positive? Tak ada pula. Anyone say negative? Tak ada. Ini tunjuk orang apa? What about K? 10K. So this one everyone agree? This one ni? Kenapa? Kenapa tu? The direction is backward. Which direction? Oh, you see the red line is that? Okay, patutlah. Interesting. Okay, ni macam that example just now. Okay. When it is drawn and arbitrary direction, it doesn't mean how to say. Okay, if you say 20i, meaning it's going forward, right? Why is it using forward and not backward? Because if it's backward there, it still seems like that, right?
Yes.
I mean, from our perspective, it's there and there, it's almost the same, right? So why do you use positive and not negative? Of course, this one is obvious because it's not here, right? But for, and Z is also obvious, you say upward. But for X, why do you assume positive and not negative? It can be also back there, right? And then negative X. Oh, negative lah. Okay, plus minus. So? Okay, right. Now, again, if you also like this, it's based on the assumption on how you interpret the drawing, right? But what's the concept that we have learned just now? Summation of f equal to 0, right?
Yes.
So if you understand this, what should be the answer then? Oh, ni P0 pula, bukan? Sorry, not P. You understand this, right? Meaning everything, summation of everything must be 0, right? So in that case, X will be what? Jangan sampai saya sudah drop. Now, okay, there's two things that I think some students still confused based on previous experience. Now, if we have, let's use the consistent color. If you have something, for example, here, and here, right? Let's say 20, 10, 10. And then, when you calculate for F, basically you add 20R plus 10J plus 10K. This is basically I add everything, right?
Yes.
To become this one. What am I doing here? Conceptually? From what we have learned? If I just add to become this one. This becomes resultant, right?
Yes.
Are we calculating resultant? No. Here is different where actually it is 4 force, right? And everything is in equilibrium, meaning summation force equal to 0, right?
Yes.
If that is the case, X component will be what? To make it 0, to make summation of F 0, it should be negative, right?
Yes.
So that it cancel that one. And then to cancel that one, negative 10J. To cancel that one, negative 10K, right?
Yes.
Then it will be summation of force equal to 0 because it cancel all of the components. Janganlah just Tapi kenapa dia duduk di atas? Because that's how the question give meaning. Okay, because otherwise you just draw the actual answer dan tak ada masalah kan. Tulis sebiji-sebiji lah jawapan ni. But that's not the question. The question is a general force. You don't know the direction. That's the meaning of that, right? So you have to use a calculation. Faham ke? Jangan mengandung kau Ustaz. Ustaz statik banyak tipu gitu. Okay, in 3D, when do you know the direction or the magnitude? When you don't know the direction or the magnitude. Okay, meaning any force that you don't actually know the direction, you don't actually know the magnitude. How many unknown do you have? 3. What are the 3 unknown? Yeah, basically like fx, fy, and fz, right? When, for example, if you have, in this case, this is an example. Okay, this is an example of you don't know the magnitude, but you know the direction, right? So the unknown will be just one, right? For example, here is the same unknown, right? But if you do not know anything like this, how will you write? If you want to write, so for example, Vxi plus Uyj plus Vz. Okay, so 1, 2, 3 unknown, right? So that's the meaning. You cannot have more than 3 because you only have 3 equations, right? Alamak. Dah boleh dah? Okay, so we have finished chapter 3. So we'll go into chapter 4. Before I go to chapter 4, any question? So, the slide only give like 2 examples of 3D, and both examples are quite simple. So make sure you just flip through some example or question in the book to see other type of question that can be asked, and if you have any problem you can raise in the next class or come to see me if you have any problem. Any question? But the concept is straightforward, right? If you can, because this part is chapter 2, right? How to get from force into vector is chapter 2. The new part is just applying summation of force equal to 0, either 2D or 3D, and then just calculation. So there's nothing much to talk about, except the question can be quite tricky in the sense that it can test you on this part. And we have covered in chapter 2, right? It can give different type of angle wherever we have covered before. So it can test you on that part, or it can test you on but this one is straightforward. If you have this one is just but now it's straightforward because we know we are learning this chapter. The issue is when you have covered everything and then you get one question from somewhere from the exam, you should know, oh, this is equilibrium, or this is resultant, or this is what, right? This is projection that you have just covered in quiz. So that's the thing that you should be able to do, because when we are covering specific chapter, obviously this is using that, right? So make sure you have enough exercise and practice to know those things. Alright, so we have finished chapter 3. We don't have the time to actually go in depth in chapter 4. We'll just touch on the space just to be consistent with the previous class. So we'll just go to the idea why we cover this one. So this is moment of force, scalar formation, cross product, moment of a force and vector formation, and principle of moment. So it is surrounding the concept of moment. How many of you have covered that one before? 1, 2, only 2 of you. The rest of you never cover. Tak ada moment manis. Okay. So okay. So you should be able to understand moment and actually calculate the moment in 2D and in 3D. So make sure you understand the concept and also can relate to the calculation. But again, just like any, I think when the final most students will, when they know how to calculate something, when they are learning that subject, but when everything is put together, they become confused because they don't know this is what, right? So make sure you understand the concept and also how to link to any calculation or equation. Now, So there are a lot of applications in real life where the concept comes into the picture, where you have to understand the effect of a certain force is not exact, is not, what's it? Okay, let's imagine, okay, before we imagine this one, right? Perhaps, because not many of us have actually done this in our life, right? But if you imagine yourself, right? For example, if you have your hand like this, because I think you can imagine this because everyone has hand. If you have some force going down in this direction, right? And the hand is supported here. This is your joint that supports this hand, right? And the force is exactly downward at this point. It's force downward, right? What type of reaction that you have to put here so that the hand stays in place? Upward. Everyone agree? Is that all? Maybe we don't have enough experience someone push it there. For example, if it's the same thing, but if we carry out a weight, right? If we have a big weight, or after we buy something from grocery or something, and it's heavy load, right? It's the same thing. You have force downward, right? Do you actually, because normally we don't hold it like this, right? But if you hold it in a certain way, right? What are the type of support that you actually place here so that your hand at an angle stays in place? Is it only upwards? Do you feel like, because it's okay different. For example, if the weight is here, right? Macam, it's your back is here. It's exactly you are pushing upward, right? So that it's not going down. But is here, is it only upward? Do you actually apply? Downwards. Do you notice that the tendency is to rotate? It's not just to go down. It's to rotate, and you actually apply some form of counter rotation. So that's how that should be captured in calculation somewhere, right? Because even though the force is here, the impact here is not just pushing it down, but it tends to also some rotation there. That to make it equilibrium, you have to counter that rotation also. So that's the issue of different placement have different effect. The same way, here is just going down. Here it also want to rotate your hand, right? So that's the concept, and we have to be able to calculate that one, right? And it's different, right? That point, the force is the same, but at this point it want to rotate clockwise. At the point it want to rotate counterclockwise, right? So different placement cause different effect, even though the weight or the force is the same. Another example is here. Can you see? This is a hammer with your hand there, and then a nail there, right? You have seen this one, right? This is also another application that we, without realizing, applying already, right? Now, the hammer, for example, yeah, we have the hammer here, this that one, right? And then we have the nail planted, and we want to take it out, right? What force need to be applied to the nail for it to come out? It should be upward so that it pluck out, right? But when you apply hammer, anyone actually pull it out? Why? Because it should go up, right? Why don't we pull up? Actually, we pull in that direction, for example. Anyone ever think about it? Kenapa kau pusing sini? Because by experience we know, right? But what concept happened there? So this is some things that we have to be able to, as engineer, to calculate what happened. And so those are the things where, how come the because when you push it, we do not drag the the nail there, right? We actually plug it out. So why is this force? How is it related to that force, right? So these are example of real case where concept of moment is applied without realizing or not. And as engineer, we should be able to calculate. Oh, okay, the force there create this because it involves rotation because we hinge here, right? Of course, if we do not plant it here, then it doesn't happen, right? So when there's a hinge here, there's some rotation, meaning this create the rotation there, and at this point it's upward. So those are the appreciation there. Alright. Same here, right? So there's a lot of things where the rotation, for example, here we apply force, but it rotates, right? we can also rotate from above like a screwdriver, right? But there's a way to produce rotation from force, linear force, and etc. Right? So these are the concepts that we will cover, inshallah, in terms of calculation, because that's the concept. Then how to calculate is what's coming next. So in the next class, inshallah. Okay, so before we end, so what there's several things. One is to return your quiz. Now, several things. One is for next class. I will announce tomorrow, inshallah, what will happen on Thursday. Because unfortunately for the class, because I am currently involved in some project that involve people in the ministry level, right? MOT, etc. So when they set the meeting, it's very hard. The minute we have to comply, and somehow they set a meeting at the class time today in Putrajaya. So I'm still trying to escape, but if I cannot, then I have to announce tomorrow whether the class have to be replaced, or I just record something and you watch for 1 hour, whatever it is. So I'm trying to hopefully, because otherwise, because we have to catch up with it. So that's one thing. So make sure you update tomorrow evening what's going on. Secondly, for those who just came in and joined the class, right after this we have to talk a bit on, because we have 3 weeks of material that we have covered, right? So it's quite crucial for me to know where you stand exactly. Thirdly, for the quiz, I think not many of you have the quiz, but okay. There are some questions that I put where I think I've already put it, right? But anyway, I think not in this class not many cases of late submission. But if you notice some minus mark of that, normally it's because you submit late. So yeah. So with regard of why or how I do the quiz, I think I explained in the first class, right? But I think some of you actually joined after the first class. So make sure you see the recording of what I mentioned in the first class, why the marking is in such a way. And one of the concepts that I think I apply is, that I mentioned, is the quiz is primarily assessment for learning and not assessment of learning. You watch it. So for learning meaning that the implication is not just to see how much you have learned, but it's to indicate that if you need to learn more, then it will show in your mark. And the time given is also, if you cannot finish on time, etc., it means that the amount of practice is still, etc. So hopefully you understand that one. Now, so brothers, you can collect the quiz before you leave, and for the system, the attendance. Everyone have signed your attendance? All right. Okay. Okay, with that, I think any other question before we wrap up the class? No? And I think I will, because of the time factor, I will also talk a bit on, I think if you have seen in the quiz, there's question number 2, that's from previous semester. So we'll go about that in the class inshallah. So we end the session here. Subhanakallahumma wa bihamdik. Assalamualaikum warahmatullahi wabarakatuh.